Welcome to this video. Completing our series in Uppaal, today's topic will be about time in Uppaal. So we'll start with an introduction, then we'll review the factors that affect the times in Uppaal. Reviewing this factor, we'll be using an example. This example is the observer example, and then later we'll see the time and queries, or how we can verify the time using some queries. And lastly, we will end with some examples. So let's get started. Time in Uppaal. Actually, when we talk about the times, so we are in somehow talking about clocks. By using the clock, we can control the times. We can control the time of the whole system. So also the clocks allow us to receive the value and test the value. The clock also is progress globally. That means if you have many clocks, it will progress in the same times. And here we say the times in Uppaal actually the same project. That's mean we can have a concurrent value for the times. So in this point, we say that time is symbolic. That means we can have we can say is the real value for the time is not work as expected. We just control the times. We just control the times. We don't have concurrent value. We don't have a real value because sometimes you just put the value, for example, x equal, for example, x is long and then x equal 5. So the time will jump to 5. It's not work as you expect and when you started from 0 and go up. Also here, the time is continuous. As we can take any value. So here we have some factors that can affect the times. So we have the first one is the transition guards. Transition guards, it can control the times as well as the location invariance. In the location we have invariance can also control the times. The third one is the channel types. For example, if we have a normal channel or we have ordered channel. So the ordered channel is affected times. The same thing is also the location types. Committed time, committed and ordered time is different than normal. The normal channel and normal location, and both of them can affect the time. So let's see how we can handle the time and control the time of the board. So here we'll take an example. And this example is called observer and observables. So actually the observer is software in many applications, and this software is used to detect the events. Detect the events without sending a message. For example, in your operating system, when you delete a file, the system should know that there is file deleted. So the observer here can be the file manager, while the system is there. So the observer here can be the file manager. So once you delete, this event should be detected and sent to the system. So as we say, we try to learn how we can control this, how we can control the time, or how the time is working over, but using an example. So the example is observer and observables. So as I explained, the observer is a software detects event from another software. We will take the simplest form of this example. Actually, we will have a loop, and this loop, or once the user press reset, so the other or the observer will detect that the user press reset. Just as I say, is the simplest form. We have loop, and in the other side we have observer. Once the user press reset, so the observer will detect this reset. So these two components is showing, or two automator. These two automator is shown in this figure. We have the observer, and this is the, can say, the observables, which is any another applications. Here in the observable, we just add a loop, and once the observer is reset the clock, so that means there is something happening. So these observers should detect that. So let's see this is one by one. So as you see, the first one is the observables. The observables is just the loop, and this loop just have a channel to reset the time, and we have also we put some guard to just to see you. Later you will see what the purpose of these guards. So here are the observers. The observers is, as we see here, two uh, two components, or two state. This is the IO, and the second is the ticket. So once the observable, or the software, or the tester, or anything is do some events, that means reset the, for example, reset the clock. So the observer should know that there is something happening. So the event is taken. So here the second part, which is the observer, and the observer just detect what happened in the observer. So here we have also after finish, after the time, or after detect this thing, that's mean the reset things, the reset, or the channel, this channel is reset. So we come here and set the value. So it's just very simple, just to see how we can control these two, how we can control the time using this example. We create one one process from the observer. We can call this process is P. So this is observer X. Observables is P. We can just create one process from this observer, and this is the observer. We can create also another process, and this is the time, or this is the process of our system. Two processors. So in our system, we will have two processors. One is from the observables, and the second from the observer. We have also the clock, which is X, and this X is reset in the observer. Also, it's controlled by the observer. We have channel also to communicate between these two time automator. Based on these two, based on the two automator, we see here, if we see here, for example, we see if X is equal to, this is as the guard here, if X equal to 2. So here the time, for example, is starting with 0, and then until X equal to 2. So the system will allow you to value this transaction. So once you value this transaction, that means you send a signal to another observer. So once you value this transaction, or once you value this edge, that means you are synchronized with another time automator, which is the observer. So This is now it's work like observable and observer. So once you the system allow you to go, so you will go to the second to the observers, and then later after that, after you go, you pass from the idle to ticking, so the time will be reset and back to the same state with this item. So if we want to present the time of x, present the value of x, the value of x here. If you want to show the value of x on this curve, actually we can say the time it's starting, for example, from 0 until 2, until after that, once it's reached to 2, it's go to another time automator, and in this time automator the time will receive. So here it was depicted here, the time is always equal or less than 2. Okay, the time will not go over than 3. Based on our observation now, you can see the time is only starting from 0 go until 2. So if the time is equal to, so it will synchronize with another time automator, and then in this time automator here actually it's committed. That means we do want to stay here, take time to in this location. We do want the clock to take time in this location, so it's just committed. That means the time is 0, and then you should move. So and then come to receive. So as we see here, as we expected, the time here will just from 0 until 2 until, and then again go to 0. And in the another circle from 0 to 2, from 0 to 2, that means will not goes over than. This is if x equal to 2. So let's see here another the same example, but we change x greater than or equal to. So in this example actually should be the same, just here we have the x can goes over that, but starting from 0 0 until 2. Here it's allow the system allow the clock to go over than 2. So here sometimes it goes maybe around 3, and sometimes it's 4, and then but will not be in here, will not be less than or less than 2. So we will later we will see, is this true? This is, as we say, this is our expected based on our understanding for the time. Okay, now we have x 0, for example, starting. Okay, so the system will not allow this time automator to synchronize with another time automator until the time is up to x 2 greater, and until the time becomes greater than 2. So and then the time will go to another or will synchronize with another time automator. So it can go over than 2 or 3, but later should be reset to 0. So as we see, this is based on our expected. So we will see how we can see that, how we can verify is our observations is correct or not. Actually, we should write some queries. We should write queries to verify these things. To verify the time in overall.